Okay, today I'm going to be testing if an iPhone still works in a vacuum chamber. So I've actually had a lot of requests to put a phone in the vacuum chamber and see if it still works. Can the radio waves still receive and transmit from a phone in a vacuum chamber? So I want to put the iPhone in the vacuum chamber and see if it can take a call. And I also want to try some other scenarios too to make it a little bit more interesting. So first I'll try the vacuum chamber, try to call it, see if it works in the vacuum. And then I'll try to call it from a completely enclosed steel container. Will that still work? And then I'll try it when it's completely submerged in water and see if a call can still go through. And then the last one I'll try is, will it still work in a microwave? So you may have your ideas on whether the iPhone will still be able to receive a call in a vacuum chamber, a steel container, or a microwave. And so why don't you pause the video right now, make your predictions, and see if you're right at the end. Okay, iPhone in a vacuum chamber. 3, 2, 1. Okay, we're already at 0.6 atmospheres. Okay, we're down to 0.2 atmospheres and it's looking all right. Okay, we're at full vacuum. Let's go ahead and give it a call and see if it works. Oh, it works. Easily works. So the phone didn't break and it can receive calls in a vacuum chamber. If only we could answer it. If you could answer it, you wouldn't be able to hear anyone talking on the other end. Let's let the air back in. Hopefully it won't break when I let the air back in. Okay, so a lot of you probably weren't very surprised that the phone could work in a vacuum chamber. I wasn't surprised either, but it's okay if you didn't know that. A lot of people get confused because we call these electromagnetic waves in this range, we call them radio waves. And so you think you hear the radio, maybe they're sound waves. If you don't know a lot of physics, it's okay if you didn't know that, but that's why I'm here to do these experiments. But yes, electromagnetic waves can go through a vacuum. In fact, electromagnetic waves don't need any medium to propagate through. But one thing that can disrupt electromagnetic waves is solid steel. So I have a solid steel container here, and I'm going to put the phone in there and try to call it and see if it still works. Okay, I've got my GoPro in here. I'm gonna close the lid, try to give it a call and see if it works. Okay, the lid is on, let's give it a call. Hey, oh, that's surprising. It works. Huh, I didn't think it would work. So the only thing I can think of why the phone was able to receive the signal in there is because this O-ring seal is not metal, so this is plastic. And so that means it can still receive radio waves in there. So they might be diminished, but you can still get radio waves that bounce down and up through and into there. And so it can receive radio waves even in this tightly sealed steel container. I have an idea though. Okay, so I'm going to try to put aluminum foil around this seal here to block any electromagnetic waves. Okay, I think I've got it completely shielded now. Okay, so the reason this was still able to receive a signal in there is because cell phones are pretty amazing. It actually needs only the tiniest bit of power to generate the signal needed in the antenna in there and be amplified to make a phone signal. So just looking this up real quick, around the minimum power needed for a wireless network is 0.1 picowatts. Picowatts is a unit of 10 to the negative 12 watts. That is an extremely low number, 0.1 picowatts. So no matter how well I sealed this, there's still, of course, a picowatt of power getting through it, and so it was still able to receive the cell phone signal. That's why your phone, with its minimal power it has, can send a signal to cell phone towers that's miles and miles away. It doesn't actually need a lot of power to generate that signal. So for that steel container, it was blocking a good portion of the electromagnetic waves, the radio waves, but it was still letting a small portion through. So for example, a different frequency of electromagnetic waves like light, so if I put it behind this paper, it does block it, but notice how it still lets some through, because this paper can only absorb so much of the electromagnetic waves, some of it passes through. Okay, so I have my phone in a life-proof case here. So we've got it in some water here. Let's give it a call and see if it works. Think it'll work? Yep, still works. So you may have heard that water blocks radio waves. So we just saw that a cell phone signal can easily get through this amount of water. If it were very, very deep in the ocean, it would likely be blocked. And that's because actually any material has some reflectance and some absorbance of radio waves. And so if you had miles and miles of water above this, the water would absorb enough of the cell phone signal so that none of it would get to your phone. Okay, for the last one, let's try it in the microwave. Okay, let's give it a call. So you may have guessed that the microwave would still work because the steel container even still worked. But the reason that a microwave potentially could block these waves is because a microwave actually operates on similar frequencies, not quite the same, but around the same frequencies as cell phones. So this metal mesh on here blocks enough of the microwaves when you're cooking food that it doesn't hurt you, but it doesn't block enough to stop cell phone signals. Okay, and actually microwaves don't block as much of the microwave radiation as you think. So I have here a microwave leak detector, and I'm going to turn on my microwave. This is just my microwave in my kitchen, and see how much microwaves it picks up. Even though we have the door closed, we have the microwave blockage right here. Let's see. This will beep when it goes over 10 milliwatts per centimeter squared. Have a cup of water in there. That's at 5, kind of jumps around. If I move it back, I'm about 1.5 feet away from it, then it stays at very low levels. But if I get any closer to the door, it goes over. So don't stick your head too close to the microwave. But just so I don't scare anyone too bad, microwave radiation isn't as scary as you might have heard on the internet. So microwave radiation isn't that bad. It's non-ionizing radiation, so it's not like getting hit with X-rays or anything. X-rays can cause DNA damage because they're so highly energetic that they can knock particles, knock your DNA apart, and so it causes defects and can cause cancer. But microwave radiation is non-ionizing, meaning it just vibrates your molecules. That's how it heats up the food. So it'll just vibrate the molecules and basically it just heats you up. But either way, it's probably not a good idea to stick your head right next to a microwave.